Now I'm going to show you how a NOT gate works using this simple breadboard circuit. A NOT gate gives the opposite of the input. So if the input is 1, the output becomes 0. And if the input is 0, the output becomes 1. In my circuit, I use a battery, a transistor, a push button, resistors, and the LED. The transistor here acts as a switch that controls the LED. When the button is not pressed, no current goes to the transistor's base, so it stays off. That means no current flows from the collector to the emitter, and the LED turns on. When I press the button, current flows to the transistor's base, turning it on. Now, the current flows through the transistor instead of LED, so the LED turns off. As you can see, when the input is high, the output is low, and when the input is low, the output is high.
Now I'll show you how an AND gate works using this simple breadboard circuit. An AND gate only gives a 1 when both inputs are 1. If either input is 0, the output stays 0. In my circuit, I use 2 push buttons, 3 transistors, resistors, a battery, and an LED. The 2 push buttons act as the inputs, and the LED shows the output. Here's what happens. When both buttons are pressed, current flows through both resistors to the transistor's base. That turns the transistor on, allowing current to flow from the collector to the emitter, so the LED lights up. If only one or none of the buttons are pressed, there is not enough voltage at the base to turn on the transistor, so the transistor stays off and the LED remains off. So, the LED turns on only when both inputs are high. That's exactly how an AND gate works.
An OR gate gives a 1 if any of the inputs are 1. It only gives 0 when all inputs are 0. In my circuit I use 2 push buttons, 3 transistors, a few resistors, a battery and an LED. Here's how it works. Each push button controls one transistor. When you press either button, the corresponding transistor turns on. That allows current to reach the base of the third transistor, turning it on and letting current flow through the LED. As a result, the LED lights up. If both buttons are pressed, both transistors conduct, and the LED still lights up. So as you can see, when either or both inputs are high, the output is high. That's exactly how an OR gate works.